Hey, Leo Dreger here. I want to talk to you about a couple different tools. We're going to use Etherape to sniff some traffic, but we're also going to combine it with a few tools. But before I do that, I want to just go through the install and get Etherape installed. So bear with me here. Let's go ahead and install this, and you can see it right in the background. Then I'll open up into the next tools. So let's do an apt-get install space ETHERAPE -Y automatically sets the install to yes, so you don't get prompted. Go ahead and install that tool, and while that's running, we'll go ahead and talk about some of the other tools that we effectively can use. Now, one of the reasons I like using Etherape specifically is because it visually shows kind of the network traffic in a very elementary way. Now, while I'm using Etherape to demonstrate the how this tool works, we're actually going to be using a tool, a denial of service tool, and it's also a sniffing tool called MACOF, MACOF. Okay, so before we do anything, let's go ahead and start Etherape. So ETHERAPE space ampersand sends it to the background. And while we have that in the background, notice we get our prompt here. That's the value of adding the ampersand to the end of your command. Otherwise, I would just have to open up a new terminal. And so we're going to see this visually run here. I just want to see some traffic. So let's do an ns lookup, www.cybrary.it. Let's see that runs. Okay, great. And we should see now some traffic on the network. So great. Everything's handy dandy. All right. So now let's look at MACOF. Okay. So let's do a manual for MACOF. Okay. Flood a switched local area network with random MAC addresses. The syntax of the command is MACOF, the interface that you want to use. You can put this or not. If you only have one interface, it really doesn't matter. Otherwise, you can choose Ethernet 0. The source, the destination, -E is the target hardware address. Then you have X port and then Y port and then the number of times that you want it to run. Now, I have to tell you, I don't think it says it in here, at least not in the help file, but this will do something ridiculous like 151,000 floods per minute, if I recall reading that somewhere in the past. If it's not that, it's something real close to it. Okay, so what we're going to do is use this very, very, very slowly. I do have to warn you, you can denial of service yourself very easily with this tool. So just do not type in MACOF and hit run. That's what we call in the IT field dumb. Okay, don't do that. So MACOF -I Ethernet 0 and the number of times, and let's just do 10 times. You can see we flooded 10 times. And we'll go back over here on the Ethernet side and then see what we sniffed. And you can actually see that this flooded basically with random 10 MAC addresses. And I have some bogus addresses in here. So it started the denial of service effect. Now this is going to stay in my local area cache table for anywhere from 30 to 60 seconds. And once that's done, and when it cleans out here in a second, you'll see it go away and pretty much go back to idle traffic. And then we're going to crank it up and we're going to have some fun. Also, while we're doing this, I want to try to do something else here. I'm going to do Wireshark as well, just so you can see what this looks like from a protocol analysis point of view. So I'm going to go to my interfaces, select my Ethernet interface or whatever one I want to sniff on, click Start, and then we can kind of see what this looks like as well. So I'm going to kind of have two tools that are going to run in the back end. One, I got my visual tool, which now looks clean, and then two, I have my sniffing tool, so that way I can see anything that floods. Okay, and then we're going to do this again, and instead of 10 times, let's do it 200 times. And I'll go ahead and let that run. And if we go back to our Etherape interface, now you can see we've got some exciting stuff going on. Right, I've effectively just flooded the network with 200 bogus addresses in just a split second. So you can imagine what this has done to the host table or the CAM table. Also, if I open up Wireshark here, you can see I'm still generating all sorts of traffic. I mean, the traffic is still going up into the it looks into the several thousands here, and it certainly will after a while. All right, so let's go ahead and take a look at some of this. I'm going to go towards the top of the list where I first started the attack and just kind of look through it and basically see what happened. So you can see right away, malformed TCP packet. Okay, so it's basically not getting any upper layer application data. Now, what this proves, all right, if you like the OSI model, what this proves is that this tool specifically works at layers 2 and 3. I know this because layer 4 and up is basically malformed. You can see layer 3 looks pretty well intact, all of the IP stuff here in terms of sources and destinations, but it's basically malformed from that point up. You can see the ARP broadcast request, and then you can see some of the DNS queries that are going on as well. And I've just generated a whole bunch of traffic. Here's another TCP malformed packet. And if I actually sort by this, TCP, enter, in a second here, it should load through, but there may be several of these in here, so it may take a second for it to actually filter through. So that should have worked. Otherwise, what we can do if we want to filter, we can do a TCP, go to our expression menu, go to TCP, and look at source ports, destination ports, or any sort of sequence numbers. Specifically, what we can do is do the flags. So it's TCP, actually it's tcp.flags.syn, and we can see if anything comes in here. Don't look like I see anything. We can do ACK. Doesn't come up, so this proves that most of the upper layer stuff is basically non-existent. Bin, right, nothing in there, so no flags. No, the TCP can be interrogated. We can look at ARP if we want. You can see that I've got an ARP request here that went out originally, okay, which looks pretty legitimate, and then an ARP reply back between the layer 3 address and the layer 2 address. So that's ARP. IP, I can look at IP traffic and just get a basic understanding, and see, look at all of this bogus TCP traffic. You know it's bogus because, again, look at the malformed packet there under TCP, all of this stuff. Right? I can just keep scrolling down here, and you'll notice the Ether2 turns yellow and the TCP turns red. And that's specifically what I'm looking for here, because that basically tells me that basically these source addresses, it can't figure out what these source addresses are. Now, they still honor the format 0 through 9, A through F, okay, but it doesn't resolve to any specific vendor. It's purely just a bogus set of hexadecimal numbers. So I can basically prove that it's bogus. And the same thing, if I look inside TCP, I can basically tell that it's bogus, because there should be so much more in TCP than what we see here. And just to double check real quick, if I go back to Etherate, you can see in 30 or 60 seconds, it'll go ahead and clear that out. So we kind of hit 2 tools here, or 3 tools really. We did MacOff, which was our attacking tool. We flooded layer 2 addresses, bogus traffic on the network. We sniffed that traffic with Wireshark, or we could have used any sniffing tool. It's just easy to do Wireshark. And then we also did it visually with Ether8. So try different combinations of this. Try using your attack tool MacOff in a virtualized environment. Always set the number N. Sniff the traffic in a couple of different ways, because then you can get creative with it. If you want to do this with T-Shark, Ethernet 0, and do it in verbose mode, whoops, let's do T-Shark-V. All right, man, T-Shark. Okay, analyze the TCP network traffic. Okay, so in this case, we don't actually have to do the -I. That was more of a TCP dump filter, so that's why that didn't work. But just T-Shark, run that. It says it's running as root, and then switch back over to our MacOff, and then run that. I'm only going to do it 20 times right now just to get the idea, and then go back over to our T-Shark. Now, the reason why I like T-Shark to do this is because the way in which that it gives you a very, very basic output of the packet. So it's just easier to read this, easier to incorporate it into some sort of comma separated or tab separated file so that you can use it later. So that's actually a bonus tool. We just threw in T-Shark on top of this. But nonetheless, the source or the attack, Macoff. On the backside, we used Wireshark, T-Shark, Ether8, or any other sniffing based tool to basically see what this traffic looks like. And there is no better way to learn how traffic behaves on a network other than actually looking at the traffic. So hope you enjoyed the lab. Let me know what you think. Make comments, share, and I'll see you guys in the next lab. My name is Leo Drager, and don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter.